The big G equation. Sarah Jane Jones, what is the big G equation?
G times mass 1 times mass 2 over r squared.
This is the equation from last year. Big G, which is just a constant. Big G is equal to 6.67 times 10 to the negative 11 newtons times meters squared divided by kilograms squared. This is the force of attraction that exists between any two objects that have mass. Now, as I said, this is the equation from last year. Note, the equation in your textbook for this year is force 1,2 is equal to negative big G m1 m2 over r squared multiplied by r12 unit vector. So notice that these are actually the same equations. It's just that the one you had last year was a scalar. The one that you have this year is a vector. So it simply indicates the direction, force that exists between objects 1 and 2. So if you have object 1 and object 2, the force of attraction is going to be, well, this is the vector, unit vector r1, 2, and then here would be the force vector 1, 2. So notice that force 1, 2 is opposite the direction of the unit vector 1, 2. So this would just be the force of attraction that exists between any two objects that have mass. If we have an object in free fall, the free body diagram is going to look like this. Force of gravity. If we sum the forces on that object in free fall, the sum of the forces in the y direction equals the force of gravity, which equals sure, mass times acceleration in the y direction. So we get mg is equal to mass times acceleration in the y direction. In other words, g is equal to the acceleration in the y direction, which is negative. You can also look at it just from a standpoint of your two different equations. The force of gravity we already have is mass times the acceleration due to gravity. But it's also equal to big G m1 m2 over r squared. In other words, G is equal to big G, mass, divided by r squared. What specifically is r in this equation? Jenkins?
The distance between the two objects?
Very close. Hadarala.
This is between the two center masses.
Between, just to be specific, just between the center of masses of the two objects. Now, this is often confused by my students. So the phrase goes like this. Class, R is not the radius. R is of the two objects. This is especially confusing because R sometimes is. So realize R by definition is not the radius. It is the distance between the center of masses of the two objects. However, sometimes it does work out to be the radius, and we will walk through that, I'm sure, today. So big G is equal, the acceleration of gravity here on planet Earth is equal to big G times the mass of the Earth divided by the radius of the Earth plus whatever your height above the radius of the Earth happens to be.